in the sky at night.
Good evening. After the excitements of the early part of 1986, things seem to be reverting to something like normal. So I thought now I'd say something about the object I personally regard as the showpiece of the sky, the planet Saturn. It comes to opposition on May the 28th, so it's now visible all through the hours of darkness, and the ring system is wide open. As I think most people know, the bright planets keep strictly to a region of the sky known as the zodiac, a belt that extends all the way around the sky, made up of 12 constellations, from Aries the ram through to Pisces the fishes. But not everybody realizes that a 13th constellation, Ophiuchus, the serpent bearer, actually intrudes into the zodiac, and so planets can pass through it. It comes down between two of the really bright zodiacal constellations, Scorpius the scorpion and Sagittarius the archer, which you can now see very low in the south. They are the southernmost of the zodiacal constellations, so they never seem to advantage from here, which really is a great pity, particularly with the Scorpion, which is a really magnificent group, and the long line of bright stars really does give some impression of a scorpion. And the leader is the red supergiant Antares, with a fainter star to either side of it. Sagittarius, the archer, has got some fairly bright stars. It's rather formless. Some people liken its shape to that of a teapot, though frankly I've never been able to understand why. And there we find the lovely star clouds which indicate the direction of the center of the galaxy. Now between those two, and crossing the zodiac, we come to Ophiuchus, the serpent bearer, with one fairly bright star, Ras Al Hague, which is about as bright as the pole star. Quite honestly, Ophiuchus is rather formless, and there's nothing there of a great deal of interest, but it is a 13th constellation of the zodiac. At the present moment, there are two planets in this area, Mars and Saturn. Mars is in Sagittarius, and you can recognize that because it is so extremely bright, brighter than any star, and of course by its very strong red color. It hasn't come to opposition yet. It'll be rather better placed later in the year. The other is Saturn, which is now right on the borders of Scorpius and Ophiuchus, and will spend some time this year inside Ophiuchus. With the naked eye, Saturn looks merely like a rather bright, slightly yellowish star, and the ancients didn't realize there was anything strange about it. There was actually no reason why they should. A little while ago, actually last March, I photographed the area. Well, that's my picture. As I say, it was taken in March, so the planets have moved a bit since then. You can see Antares with its flanking star over to the right side. Saturn's near the top, and Mars is near the bottom. And with that, you can see that Saturn, with the naked eye, does look like a perfectly ordinary star. But once you use a telescope, the situation is very different. I'm afraid binoculars won't do for this. Good binoculars will show there's something unusual about Saturn's shape, but to see the ring system, you do need a telescope. And a small telescope will show the ring system quite clearly. This is a small-scale photograph that I took some time ago, and I think it does give a pretty good impression of what a small telescope will show you on Saturn. The yellowish, flattened disk, spinning around quickly. After all, Saturn has a rotation period of less than 11 hours, and the ring system is there. And bear in mind, too, that although Saturn may look small, it really is a large world, over 70,000 miles across, very much larger than the Earth, and not very far short of 900 million miles from the Sun. Now, in fact, that picture shows what Saturn looks like through a small telescope, and binoculars won't show the rings at all. Neither will really small instruments, and I think it's hardly surprising that when telescopes first came along in the early part of the 17th century, the observers were very much puzzled by Saturn. And that even went for the first great telescopic observer, Galileo, who began his observations in the early part of 1610 with a telescope he made himself, and made a whole series of spectacular discoveries. There are some early telescopes. Galileo's among them, it's the top there. It was very weak by modern standards, and the most powerful telescope he ever made only magnified 32 times, but it was good enough to do a great deal of work. He discovered the craters of the moon, the phases of Venus, the 4 main satellites of Jupiter. He found that the Milky Way is made up of stars, and so on. But Saturn really was a puzzle. And when he first looked at it, well, here's the drawing that he made. He was under the impression that Saturn was a triple planet with a large body in the middle and 2 smaller ones to either side. And great was his surprise when a couple of years later, in 1612, he found that the smaller bodies had disappeared. And this is what he said, in translation, of course. What is to be thought concerning so strange a metamorphosis? Are the two lesser stars consumed after the manner of the solar spots? Has Saturn perhaps devoured his own children? Or were the appearances indeed illusion or fraud? The weakness of my understanding and the fear of being mistaken have greatly confounded me. But now we know exactly what had happened. Saturn's rings are very broad. They measure nearly 170,000 miles from one side to the other, but they are also very thin. And when they are turned edgewise onto us, they practically vanish. And there's a drawing that I made of Saturn last time the rings were edgewise on, and I was using one of the world's most powerful telescopes. You can see details on the disk there, which Galileo certainly couldn't. You can only just see the rings as a thin line of light coming out from either side. And obviously, Galileo's feeble telescope lost them completely, so he had no idea what they were, and that was one thing he never did discover. Neither did the observers who followed him. There was one, the French astronomer Pierre Gassendi, a pretty good observer, and he made drawings of Saturn, and he also failed to identify the rings for what they were. There's one of his early drawings, made in 1634, and that doesn't show very much, frankly. But here's one made in 1636, and that's much clearer. And a drawing made by Gassendi in 1651 really should, I think, have given him the clue, as you can see the rings there. But he didn't interpret them, and neither at that stage did anybody else. And in fact, all kinds of strange theories were current. It was thought that Saturn might be a world with dark spots on it, or there might literally be handles, or there were several satellites, some bright and some dark. No one really knew. And the man who finally cracked the problem was the Dutch observer Christian Huygens. He was probably the best telescopic observer of the mid-17th century, and we also remember him for his connection with the pendulum clock. But the telescopes Huygens used were better than Galileo's, but by modern standards they were very strange indeed. And there's a picture of one. The object glass is actually fastened to a mast at the top left, and the tube, if you can call it that, extends from top left down to bottom right. And the observer had to look at the eyepiece at the bottom of the picture. And how anyone managed to see anything at all with a telescope of that kind, frankly, I simply don't know. The reason was that the very small and imperfect object glasses gave a great deal of false color, which, to an astronomer, is an unmitigated nuisance. And the only way to get round that at that time was to make telescopes of immensely long focal length, so they were incredibly clumsy. But Huygens did manage to have some good views of Saturn, and in the mid-1650s, he not only discovered Titan, the main satellite, he also realized that Saturn is, in his own words, surrounded by a thin, flat ring which nowhere touches the body of the planet. And in 1659, he published a book about it, and here's a drawing actually from his book. Sun in the middle, Earth's orbit. Saturn's rings, of course, always keep the same angle, but in the outer circle here, you can see the changing view as seen from the Earth. Sometimes the rings are well displayed and cover one pole of the planet. At others, they are almost or quite edgewise onto us, and small telescopes lose them completely. It seems very simple now, but Huygens was the first man to realize it, and strangely enough, that theory took some time to be accepted, and the other theories remained current for some years. One man who did accept it was the great architect Sir Christopher Wren, who began his career, remember, as a professor of astronomy at Oxford. And Wren had his own theory about the rings, that as soon as he heard Huygens, then he abandoned his own theory because he realized that Huygens was right. Not everyone was so far-sighted, but in fact it was in the middle of the 1660s that the ring theory was finally proved beyond a shadow of a doubt. And one man responsible for that very largely was an Italian whose name was Giovanni Cassini. Well, he spent much of his life in France. He was called to France by King Louis to direct the new Paris Observatory, and he was a very good telescopic observer indeed. And there's an old engraving of the Paris Observatory as it was round about 1670. And there's quite a story attached to that one, because King Louis wanted the observatory to look nice, and Cassini, rather naturally, wanted to use it as an observatory. And the two ideas didn't mix. And as an observatory, the original building was completely useless, because, for one thing, the roof got in the way of the telescopes. And the story is that Cassini had to take his long focus refractors outside to make use of them, and one luckless observer actually had to sleep on the veranda. But getting all round that, Cassini did make some good observations. He discovered 4 of Saturn's moons, Titan, Iapetus, Rhea, and Dione, and he also discovered the famous division now known in his honor as the Cassini division. And there's a picture of Saturn drawn by Cassini in 1676, There are the rings, and that dark line in the rings is actually a gap. And until fairly recently, we thought that that Cassini division was literally empty. So the ring system was made up of two, a bright inner ring, ring B, and a slightly duskier outer ring, ring A. It's not the only division. Another one was discovered in the 19th century by the German astronomer Encke. And here's a drawing of Saturn that I made some time ago with my own telescope, which does show the Encke division. There again we have the disk of the planet. That broad gap is the Cassini division. And outside that, in ring A, there's the very much narrower Encke division, which isn't all that easy to see unless you have a fairly big telescope. So we have the two bright rings, the two divisions, and inside the bright rings, the semi-transparent crepe ring, or dusky ring, discovered way back in 1850. And we thought that the ring system was fairly straightforward. Two bright rings, two divisions, and one dusky ring. So far as the composition was concerned, well, we really go back to the year 1705 with a suggestion by Cassini's son, Jacques. Now, he was the first to point out, I think, that you can't have a solid or liquid ring. Because Saturn is a very large planet. It's 95 times more massive than our Earth. And if a solid or liquid ring could form, which actually it couldn't, it would promptly be torn to pieces by Saturn's very powerful pull of gravity. And we now know, and have known for a long time, that the rings aren't like that at all. They are made up of swarms of small particles, mainly ices, all of which are spinning around Saturn in the way of tiny moons, and so close together and so far from us that they give the misleading appearance of a solid ring. But what about the actual planet itself? There was a theory, current until our own century, that Saturn, like Jupiter, might be a miniature sun, actually sending out enough light and heat to warm its satellite system. In 1882, the first important book on Saturn was written by the British astronomer R.A. Proctor, and here's what Proctor had to say about Saturn's surface. Over a region hundreds of thousands of square miles in extent, the flowing surface of the planet must be torn by subplanetary forces. Vast masses of intensely hot vapor must be poured forth from beneath, and rising to enormous heights must either sweep away the enwrapping mantle of cloud which conceals the surface, or must itself turn into a mass of cloud. And above that, of course, there will be the ring system. It's a lovely theory, but completely wrong. And in the 1920s, it became quite clear that Saturn's clouds, at least, are cold, and there's no suggestion that Saturn can be a miniature sun. There is a very major difference between a star and a planet. A star shines by its own light, by nuclear reactions, and to do that, the core must have a temperature of at least 10 million degrees. Well, Saturn's fairly hot inside, but the core temperature can't be more than about 12,000 degrees, so there's no chance whatever that nuclear reaction will start, and Saturn can never be anything like a sun. It does send out rather more energy than it would do if it depended entirely upon what it gets from the sun, but that doesn't mean it's a star, and it doesn't send out any appreciable heat. And today, we have a very good idea of what the structure of Saturn is. The outer atmosphere is made up very largely of hydrogen, together with hydrogen compounds and a good deal of helium. Inside that is liquid, mainly liquid hydrogen. So Saturn is mainly a liquid planet. And inside that is the solid silicate core, and the overall density is actually less than that of water. It's been said that if you could drop Saturn into a vast ocean, it would actually float. Of course, all our knowledge of Saturn has been revolutionized in recent times by the two Voyager probes, which bypassed Saturn in 1980 and 1981 and sent back pictures far more detailed than anything we could obtain from Earth. Here's one typical view. There's the yellowish flattened disk. You can see their cloud belts, much more muted than Jupiter's. Saturn's a blander kind of world. There's a thicker overlying layer of haze. You can see the rings, the Cassini and the Encke divisions. You can see the shadow of the disk on the ring to the upper right there, and also the shadow of the ring on the disk. But there are clouds on Saturn too, and here's a Voyager picture of the northern hemisphere. Of course, this is a false color picture. The colors have been enhanced, but there are colors on Saturn. You can see there are whirls and swirls, and in point of fact, on Saturn, the winds are extremely fast, faster than on Jupiter. Near Saturn's equator, they can blow at something like 1,000 miles per hour. And Saturn has a red spot. And there's a picture of Saturn's red spot sent back by Voyager. You can see it there quite clearly. It's nothing like Jupiter's red spot. The red spot on Jupiter has now persisted for several centuries, and it's got very definite structure, and it dominates all that part of the planet. Saturn's red spot's quite different. Whether it still exists is something that I can't tell you, and frankly, neither can anybody else. You can't see it from Earth. It's not prominent enough. And so I think we've simply got to wait until another probe goes past Saturn, sends back close-range pictures, and tells us whether that red spot is still there. My bet is that it probably won't be, but of course I could be wrong. And then there were the rings, which turned out to be utterly unlike anything we'd expected. There's a picture of the ring system from Voyager, and as you can see, there are literally thousands of narrow ringlets and narrow gaps. Nothing could be more different from the old picture of two main rings, two gaps, and one transparent ring. And just why are the rings like that? There are even narrow ringlets inside the Cassini division, once thought to be empty. When we thought there were only a few divisions, they were put down to the gravitational pulls of Saturn's satellites. Well, I think we've now got to realize that that explanation is not adequate to account for all the thousands of narrow ringlets and divisions we see. And the dynamics of Saturn's ring system are still very much a matter for debate. It looks to me very much like some kind of a wave motion, and I'm sure the satellites are involved in some way, but we certainly haven't solved all the mysteries yet. There is, of course, an extensive satellite system. Altogether, 20 satellites are now known, some discovered by Voyager, and they are a very varied bunch indeed. Some of them are imaged from close range by Voyager. There is Enceladus, with an icy surface, partly in small craters, and some parts with no craters at all. Then there's the small satellite Mimas, with that huge crater. There is Hyperion, shaped rather like a hamburger and darker than the others. There is Tethys, several hundred miles across, and mainly a ball of ice with grooves in it. And there is the mysterious Iapetus, one of Cassini's discoveries in 1671, half bright and half covered with a darkish deposit. Now, Cassini had realized that Iapetus is variable. When west of Saturn, it's very much brighter than when to the east of Saturn. And we now know why that's so. It takes 79 days to go around Saturn, and when it's west of Saturn, the dark side is turned towards us because the rotation period is the same as the revolution period. When west of Saturn, you can see Iapetus with a small telescope. Let me show you where to find it if you have got a telescope. This picture is shown with south at the top, as most telescopes show it. Saturn in the middle, and here is Iapetus now, May the 1st. It moves east and it fades as it goes. It'll be fainter on the 10th, and later in the month it'll be considerably fainter still, although of course it'll brighten up again in June as it comes back west of Saturn. But the largest satellite, discovered by Huygens, is Titan, which is bigger than Mercury, bigger than our moon. Voyager couldn't show the surface. All it could show was the top of a layer of orange smog. And that thick atmosphere is mainly nitrogen. And underneath, Titan must be a remarkable place. There may be oceans of liquid methane, cliffs of solid methane, and a methane rain dripping down all the time from the clouds in the nitrogen sky. And we'd very much like to know what Titan's really like. But you can see it with a small telescope, and here again is where to find it. There's the position on the present time, May the 1st. It moves around Saturn in a period of 15 days, and you'll always be able to follow it. Any small telescope will do, and I believe some keen-sighted people have even seen it with binoculars, although I never have myself. But Titan's certainly easy to find. Not so the outer satellite, Phoebe, which goes round Saturn the wrong way, like a car going the wrong way round a roundabout, and that's the only picture of it sent back by Voyager, and it doesn't show very much. But we do know that although Phoebe takes 550 days to go around Saturn, it takes only 9 hours to spin once on its axis. It's not like the other satellites, and it's probably a captured asteroid. So, as you can see, there's a great deal of interest in Saturn. And even if you haven't got a large telescope, there are things you can observe. So if you've got any kind of telescope at all, do go out now, look low down in the south, between Scorpio and Sagittarius, and there you will see the lovely planet Saturn. And with any kind of a telescope, you will be able to make out the ring system. And of course, Halley's Comet has returned to our skies, and you will find it after dark, low down in the south. By now, it's reached the area of the constellations Corvus and Crater, and here are the positions. 27th of April, then it tracks up through Crater, 1st of May, 15th of May. It's below naked eye visibility now, but binoculars will show it as a fuzzy blob with indications of a tail. It's fading quickly as it moves away from the Earth and the Sun, but binocular owners will be able to follow it for a couple of weeks yet, until the moon becomes obtrusive once more. After that, you'll either have to use a telescope or wait until the year 2061. Of course, the comet was at its best from the southern hemisphere a few weeks ago, at the time when David Malin in Australia took this lovely picture of it. But though it hasn't been brilliant, Halley's Comet has taught us a great deal. And in our next program, before we say farewell to our most famous cosmic visitor, we'll be giving you the results of the Giotto probe's encounter with the comet last March the 13th. Until then, good night.
Tonight's edition of The Sky at Night has a second showing on Saturday afternoon on BBC Two at 4:40.